So we're going to go over the quiz number 4.
Exactly.
Okay, so we're going to be going through quiz number 4. Okay, so question number 1, another term for attenuation is another definition. It's a definition of the amplitude reduction. It's attenuation. The answer is C as in cat for number 1. Okay, for number 2, for an inverting amplifier to reproduce input signal with a wide range of frequency, the amplifier should possess, mainly you need to possess a wide band or high bandwidth. So the answer is B as in Bob for number 2. Okay. All right, for number 3, the bandwidth of an inverting amplifier is measured at, okay, so number 3, the minus 3 dB, that's the same thing as the breakpoint frequency, same thing as critical frequency, and also known as the cutoff frequency. So A and B, it's the same thing. So the answer is C as in cat for number 3. So we have any question on number 1, 2, or 3?
No.
Okay. Okay, number 4, based on the given circuit information, the correct circuit current ignored direction is R. Okay, so if you do this calculation, IL, IF, IN, all of them is 1 milliamps. So we did all the calculation right here. So we got the gain and then we do the calculation and then use that information to calculate IN, IF, IL, all of them comes up to 1 milliamps each. And so therefore A, B, and C are correct. So the answer is D as in David for number 4. So any question on number 4? Okay, next. Okay, the inverting input of this op amp is mainly, okay. So the at the op amp at the inverting input would be right here. It would be the same thing as virtual ground. Okay, so D as in David for number 5. Okay, any question on number 5? No question. Okay, number 6. Okay, to increase the circuit gain. Okay, so increase the circuit gain, we can increase RF or decrease RN. So the only one that is correct is B as in Bob for number 6. Okay, any question on number 6? Okay. Number 7. If the circuit load resistor is very within design limit, circuit voltage gain will remain the same. This is the formula for gain, okay? It has nothing to do with load. You only have to do with RF and RN. Nothing had to do anything with the load. So therefore, everything's remained the same. So the answer is A as in apple for number 7. Okay, any question on number 7? Okay. Number 8, for DC applications, the gain of the inverting amplifier circuit essentially equal to, so that is, so to calculate the gain, so A, voltage gain equals negative RF over RN, okay? So the answer is B as in Bob for number 8. Okay, any question on number 8? Okay, no question. Next one. Okay, 9. The circuit output voltage can be increased by, okay, so now the signal, so Vout can be increased. Okay, you can increase you can increase here the RN, that would increase the output voltage, or you can decrease R1, that would increase the voltage, or you can increase the voltage input VI. So therefore, all of them is correct. So the answer is D as in David for number 9. Okay, so any question on number 9? Okay, no question. Next one. Okay, number 10, a decrease in circuit bandwidth result from an increase in value of, okay, so in order, so decrease in bandwidth, so decrease in bandwidth, therefore it had to be increase in the gain. So in order to increase the gain, either gain the R2 be increased or R1 is decreased. Let me see if I can put that into blue. Okay. So either one. So they said increase in value. So increase in value, it had to be increase of R2. So the answer is C as in cat for number 10. Okay. This op-amp is balanced and not saturated if the potential at the inverting. So inverting is would be right here. Okay. Is at virtual ground? No, equal the potential of the non-inverting input. So in right here, so VI, it had to be this VI down here, it had to be VI right here. That value would be had to match in order for prevent it from going to saturation. So the answer is B as in Bob for number 11. Okay. Any question on number 11? Okay, no question. Next one. If an input voltage of 0.2 VDC is applied to the circuit, the output voltage is, okay, so before we can find out the output voltage, we have to calculate the gain. The gain, this one is non-inverting because it's on the positive side where the input is coming in. So therefore your gain would be 1 plus RF over Rn. So therefore 1 plus 9 kilo ohms divided by 1 kilo ohm. So this is represent 9 plus 1 will be 10. Okay. So V out equal gain times V in. So 10 times 0.2 VDC equal 20 volt VDC. So the answer is D as in David for 12. Okay. All right, so next one, 13. In this circuit, the value of R1 is increased as a result, the circuit gain and bandwidth, okay? So if R1 is increased, if that one's increased, the gain would decrease because that's inverse proportional. So increase here, decrease the gain. So if you decrease the gain, you're going to increase the bandwidth. So therefore you decrease the gain. Okay, A would be correct. A as an apple, decrease the gain, and the bandwidth would be increased. Okay, so the answer is A as an apple from number 13. Okay, any question number 11 or no, number 12 or 13?
So Sam,
Yes.
the number 12, 10 times 0.2 is 2 volts DC.
Oh, sorry. Yeah, that's correct. I got it. Okay, that was correct as it was. Sorry. Okay, thank you. Okay. That was correct. Okay, so that's corrected. Number 12 and 13. Okay. Thank you, Hernando. Okay, any other question, number 12 or 13? No question. Okay. Number 14. Okay, so and this is the circuit gain is 10 and Rn is 5 kilo ohm. The feedback resistor RF is, okay, so this one is non-inverting. So we know that first we have to look at the gain. So AV equals 1 plus RF over Rn, and we have to calculate this one. So we move the 1 to the other side by subtracting the 1. So that means the gain is going to be -1. And then after that, we multiply the Rn to onto the right side. So therefore, the gain -1 times the Rn. So now we got the 10 minus 1 times the 5 kilo ohm. So this one be 9. 9 times 5 be 45 kilo ohm. So the answer is B as in Bob for number 14. Okay, any question on number 14? Okay, so look like a majority of the people did not do so well on this quiz. So make sure that most of you need to go back and read the handout. Okay, so make sure you be able to. So make sure you go through this. Do this exercise, doing this quiz many times so you can be familiar with it. And everything that I do the calculation here, it's all I got it directly from the formula from the website or the formula from the from LabVault. Okay. All right, so that's pretty much it. Okay, so any other question or any concern for anyone?
Dan, would you show 4 again real quick?
Number 4. Okay, so this is 4.
All right, thank you.
All right. So back to you, Mr. Pham. Thank you.
You Sam.
You're welcome.
Okay, let me share my iPad. Okay, last time we already done part of the JFET. Okay, so when you're looking into the symbol of the JFET, you have to recognize is it the N channel or the P channel. Okay, basically depend on the arrow pointing in or pointing out. Okay, and this for N channel. So basically N channel, they will be applied VDD positive and negative, and VGG negative and positive. That will be opposite to the P channel. P channel, VDD will be negative and the positive. And VGG will be positive and negative, just opposite. Okay. On this one, they just telling you one thing. Okay. When you try to get the VGS more negative, that will be when they measure the current, they will be less. The thing is that is a channel from the drain to the source. Okay, when they wider, more electron moving, then you get more current. Okay, and if you're looking on the second one here, okay, they reduce the negative VGS. That is telling you the current will be increased. That also same thing. Okay, more, you get a less negative VGS, then now to get a more current. You see the channel between the drain to the source. Now they wider. Okay. Okay, and also try to understand on this thing here for N channel. Okay. This is the point A right here, and this stands for the current ID. Okay. And when the current ID, okay, and the voltage VGS equal VP. Okay, you're going up, see here. When the VDS equal VP, and now the current ID will be constant. Okay, and that's what they call ID at F. And what they said, ID at F, that is the maximum current with VGS equal 0. That's a very important. Okay, and when you get exist some VDS voltage, and now they will be breakdown. Okay, so basically they get one region here, one in this area, and this is outside. So from a 0 up to VDF, the JFET will be using at ohmic region. Okay, that means they can use it as a resistor. And from VP up to the breakdown, that's what they call a constant current area. That means the volt current is no change, and they will be I equal ID at that's the maximum current. Okay, and this is a summarize something. Try to read over. Maximum drain current of JFET occur when the gate short voltage is 0. That means VGS shorted. The drain current is almost constant in the region between VP and VDS maximum. If the drain voltage is too large, JFET will be breakdown. JFET act like current source when it's operating along the almost horizontal path of the drain curve between minimum of V ping off and the maximum of VDS max. Okay, the minimum voltage of VP is called a ping off voltage. The maximum voltage VDS max, that's called breakdown voltage. Between ping off and a breakdown, JFET act like current source with the value of the IDSS. So IDSS stands for current from drain to the source with shorted gate VGS equal 0. An ohmic region, almost vertical part of the drain curve equal ohmic region that equivalent to the saturation region of the bipolar transistor. Okay. Cutoff voltage. The value of VGS that make ID approximately 0, what we call a cutoff voltage. So at the VGS off, ID equals 0. The JFET must be operated between VGS and VGS off. Okay. Comparison of ping off and a cutoff. VP is the value of VDS at which the drain current becomes constant and is always measured at VGS equal 0. VGS off and VP are always equal in magnitude but opposite in the size. Okay, normally data set they usually given either VGS off or VP, but not both. That's a very important thing you must be know. If you know VGS off, you know VP. Or if you know VP, you know VGS off. Okay, and now on that one again, you can see that stands for ID. And that for voltage VGS minus 4 volt, VGS minus 3 volt, and so on. So basically, depending on VGS, you can get the current ID. So JFET is the voltage controller. Why voltage controller? The thing is, you want to get the ID, you change VGS, okay? But in the bipolar transistor, NP and PNP, that's what we call current controller. Okay, the thing in bipolar IC equal beta time IB. You change the current IB. You change the current output IC. That's what we call current controller. Okay, at this display here, they're just telling you at cutoff ID equal 0 and the VGS, okay, equal VGS off. That's only telling you at the VGS off, basically the channel open, no current electron can be flowing. So that's why ID equal 0. Okay, that one we already done. That one we already done. Okay, and that be the curve for the ID. Okay, at this point here, VGS equal 0, ID equal IDSS. At the point here, VGS equal VGS off, but ID equal 0. Okay. And then that curve, you can calculate the curve in here by this formula. ID equal IDSS times 1 minus VGS divide VGS square. Okay, on this side, they display for you what the voltage VGS, okay, equivalent any point on the curve. You can get ID and you can get VGS, okay. Okay, this example we already done last time. That's what they're talking about, forward transconductance. Forward transconductance, transfer conductance, GM, is the change in the drain current for a given change in VGS. So by definition, GM equal delta ID divide delta VGS. So at a certain point, you can get delta of ID from this point to this point. And also you get a delta VGS. So you take a delta ID divide delta VGS, you get a GM. But we don't care much about that thing, okay? We care about how do we calculate VGM. VGM equals GM 0 times 1 minus VGS divide VGS off. And then they said data sheet normally give the value of GM at VGS equal 0. So that's what we call GM 0. So the question is they can ask you, okay, what is the GM 0? The answer will be transconductance at VGS equal 0. Normally the data sheet give it to you. However, if they not, you can calculate GM 0 equal 2 times IDSS divide absolute value of the VGS off. Think the VGS off is negative, and GM 0 cannot be negative number. So that's why you need an absolute value. Okay? And this one done. Now, today we really concentrate on JFETDCBias for the JFET. You understand they're using the transistor bipolar or JFET for the amplifier. However, either bipolar or the JFET, they need the DC power supply to make the JFET working before they can try to be the amplifier. Okay, the most common biasing technique. Okay, going to see how they doing bias in JFET. They can get the first one will be a fixed bias. A second one we call a cell bias, and the next one will be voltage divider bias. That three things we concentrate on, and the last one, current source bias. We don't need much thing up there. Okay, now this circuit shows you for the gate bias or fixed bias. That means you can say you can get the gate, drain, and the source, and you get VDD 20 volt. And also RS here, okay, or RB, whatever label, and you get a negative voltage here. Okay, basically, G here, the value very big, over mega ohm. So basically, the current on this side cannot go to on this side. The reason is the resistor get too big. Okay, so that will be telling you another thing. The voltage V minus VGG will be the same voltage at the gate. Okay, so that will be bring it up. The problem is, do we need that resistor or not? The thing is the voltage here and here it will be the same. Okay, if you take it out, they still be the same. And now why do we need this RG here? It will be showing you when they be an amplifier. That means the input you get a sine wave, and the capacitor will be DC blocking AC coupling. So you get a sine wave on this side, you get a sine wave on this side. Now, when you're converting DC circuitry to AC circuitry, VDD must be drowned, VGG must be drowned. Okay, and they show you on this picture here, if you don't have a resistor RG, so VGG AC route, they will be short the sideway to the route. So that's why they cannot be working. Okay, that is the reason why we need the RG. They can be 1 mega ohm or higher. If you get any question, just let me know. And now this is another one. Cell bias. The thing is, sometimes you have solving the very simple problem. However, in order to do it, you have to recognize what type of bias of the circuitry. Okay, in the second one here, they call a cell bias. You see the difference. The cell bias, they don't have any voltage here. Okay, no more voltage. So in order to solving for the cell bias, that means you have to calculate ID. Okay, IS, VG, VS, whatever. So in this one, they don't want to using the formula to calculate the ID. ID, like we see the last time, equal IDSS times 1 minus VGS over VGS of square. That's a very, very difficult to using that equation for the cell buyer. So that's why they said on the single power supply yield, okay, and also you need the graphic, okay. That means they given you the circuitry cell bias, also they have to given you data graphic to telling you how can we do the calculation. Without this graphic here, very, very difficult to calculate the DC bias for the cell bias. When we go detail on that, then we'll be telling you how can we do. And the next, voltage divider bias. So basically, that's a voltage divider bias here, okay? First thing you can easy to calculate the VG right here. Voltage divider. You take a VDD times R2 divide R1 plus R2. That's a very simple, okay? They say, since the gate source junction has extremely high resistance, the R1 minus R2 voltage divider is practical unloaded. Voltage divider bias is more stable than either gate or cell bias. However, you still need the graphic.
Mr. Pham,
Okay.
is there a way you can write the what like the how to that the VDD times R2 and all that?
The thing is, normally you want to calculate the bias, you need to calculate the ID. ID equal what? IDSS times 1 minus VGS over VGS of square. That equation very, very difficult to calculation for either cell bias or voltage divider bias. And they try to get away from using that equation. So that's why they given you the graphic. That will be more easier to solving the problem. So that's why they say need graphic.
Thank you.
Yeah. Okay, now you can see that is basically for the current source. Okay, you get the time, you can read through it. I given you example. Also, I given you the solution. This just normal, almost like fixed bias, but a minor difference. Now, for the voltage, for the cell bias, okay, this we're talking about more detail here. For the cell bias, we said we don't want using the formula to calculate the ID. Normally, they given you this graphic. Okay, this is the graphic here. Okay, what we try to do is try to calculate the Q point. That's the Q point here. Okay, at this point, you know what ID equal, and you know what VGS equal. Okay, that means for the bias, normally you have to calculate VGS and ID. Now, how come they do? they given you this circuitry. They given you that graphic. And they said, for JFET and the graphics show, they want to know what ID, Q. That means the Q point. What we will be doing. Okay, see, VGF equal VG minus VF. And the VG is right here, 0. Okay, so 0 minus ID times RF and will be equal minus ID times RF. Okay, this is the equation we'll be using. Okay, VGS equal minus ID times RF. In order to do it, first thing they say, we need 2 points, A and B. Okay, and draw load line. Okay, first thing they want to know what first point will be A. From I minus ID times RF. First thing at this point here, ID equals 0. Okay, and VGS also equal 0. So you get the first point, say A here. Okay, and now we need the second point to draw the load line. Okay, point B. Set ID equal any value. Okay, will be greater than 0 and less than ID equal ID at that. So that means you can pick any value of ID from here. They don't care. You can pick at this point, or this point, or this point, or this point. Okay, after you get this point here, okay, they say select ID equal 10 milliamp. That means right here. Okay, then VGS equal 10 times RS, you get minus 4.7 volt. That is a 4.7 volt. So you get to draw the line up and draw the line from ID. And that point you get the B. Now you draw the load line A to B. They cut the curve at any point. That's what we call a Q point. So you go to the right, you get ID. You going down, you get a VGF. So in here, they already telling you IDQ, they get 4.8 milliamp. That means 4.8 milliamp here. And also VGSQ, you going down here. They will be minus 2.5 volt. Okay. That's the easy way to show for the fixed bias. However, if you open the textbook, electronic for technician, they're not using this thing much. Okay? Engineer, they will be go to it. But technician, no. Okay, they given you another way. Simple to calculation. And now we're talking about voltage divider bias. For this voltage divider bias, okay, first thing you easy to calculate the VB. Okay, and you understand the VB right here. Gate, source, and drain. Okay, VB calculate by voltage divider. You take 12 volt times R2 divide R1 plus R2. That's what we already calculate right here. 4.8 volt. Okay. And now from here to here. Okay. You understand this is good. VGS. See what they calculate. VGS equal VG minus VS. Okay. And all the time in the JFET, you must know ID always equal IS. That's a very important. Okay. So VGS equal VG minus ID times RS. That will be 4.8 volt minus ID times 3.3 RS. Okay. So VGS equal 4.8 minus ID times 3.3. Okay. And that's what you can get the VGS. But the thing is you need the ID. Okay, ID right here. So, same thing. You use the graphic. Okay, this is a graphic here. This given to you. And now they said you need 2 points to draw the load line. First point will be A right here. Then the second point, you can get a B right here. Okay, you draw this line. When they intersect with the curve, that's what you get, the Q point. You want ID, you go to the right. You want VGS, you going down. So the important is how can we draw, get the point A first. In here they already explained to you. To get point A, set ID equal 0. Okay, you know the formula, the equation in here. This is the equation we're working with. So to get the point A, you set ID equal 0. Then VGS equal 4.8. Okay. Let's see. Minus ID time 3.3. However, ID equal 0. Okay. So you get 4.8 volt. That's what you get right here. Okay. And now you need a second point. To get point B in this equation. Okay. Set VGS equal 0. Then 0 equal 4.8 volt minus ID times 3.3K. Okay, and ID times 3.3K. Okay, equal 4.8 volt. ID equal 4.8 divided 3.3. You get 1.45 milliamp. That's what the second point right here. You draw the load line. Intersection right here we call a Q point. You want to get ID, you go to the right. You want to get a VGS, you going down. Therefore, voltage divider. Okay, if they given you the circuit voltage divider here, they want you to calculate it without the graphic. That's a very, very difficult to do calculation. So if they don't want to give you the graphic, then they have to give you something else. I given you the example. They say, okay, I given you VD equal 7 volt. Okay. Now, then you don't need the graphic. You still can calculate the ID. You can see ID will be here. Okay, the difference between VD and VDD. Okay, divide by RD. That's what you get, ID. And you get the ID. Same thing, you can get the IS. ID, IS will be same thing. Okay, when you get the IS, you're able to calculate the VS. VS equal IS or ID times RS. And now if you get the VS, easy for you to calculate the VGS. VG minus VS. VG you calculate using voltage divider. VS you can calculate when they given to you the value of the VD equal 7 volt in this example. So you don't need the graphic. Most of the textbook for the technician, when you try to working with DC bias for either voltage divider bias or cell bias, they given you extra value. So you don't need any graphic. Okay, so any question, okay, about cell bias, fixed bias, and voltage divider bias. Okay, if you get the time, okay, then you can try to see how can we do it for this example. This is the cell bias. Okay, they given you the graphic and they want to know what VGS Q. Q means the Q point. IDQ. That means also that for Q point. And also they want calculate the VDS. You understand the VDS? That means the voltage from the drain to the source. That will be equal VD minus VS. Okay? And if you get the ID, easy for you to calculate the VD. Okay? And VG, you know VG, voltage at the gate equal 0. And the VS equal ID times RS. Okay, so first thing, you think you can calculate for me the Q point. That means VGSQ and IDQ using the graphic. V1 IDQ and VGSQ. That means any point in the display. In order to do it, okay, and basically you can see VGS VG minus VF, okay, equal what? What VG equal? Is right here. Great. That will be a short. VG equal 0, right? Minus VS, that's the current flowing here. IS or ID the same. So equal ID time IS. And finally, they equal minus ID time IS. IS will be equal for 170 ohm. So, like we already said, you need 2 points. First thing I need from A. Okay, that's the VGS. Now, at the point A, so you say set ID equal 0. So what VGS equal? Okay, VGS equal minus ID time RS. Now if you select ID equal 0, that's telling you VGS also equal 0. That given you the first point. A will be at this point right here. Okay, and we need the second point, point B. In the point B, they say, okay, you can select ID equal any value between 0 and 10 milliamp. I can pick it 1, 2, 3, 4, 5. Okay, I set that equal 1, 2, 3, 4, 5. Okay, so you say set ID equal 5 milliamp. So you get the equation VGS VG minus VF. Okay, VG you know equal 0 minus VF, and VS will be equal ID time RS. And you already know ID equal 5 milliamp. And RS will be 470 ohm. So you can get the VGS equal, let's see, 5 times 0.470, 2.35. Okay, so basically -1 -2, okay, -235 maybe here, can any point. Okay, you draw from the 5 here, okay, 5 milliamp, draw the line. And draw the line from -2 point. Okay, they will be come up here. They intersect right here. So this is what we call a Q. Q point here. Go to the right. You get the ID. Okay, and you going down. You can get the VGS. That we just go through what we already showed you before. And this also, they do it calculation like we just did it for you. Okay, first point, you get point A. And second point, you get point B. Okay, on this one, they're using 10 instead 5, like we did. That on the different. Now, on this example here, this is a cell bias. However, without graphic. See that? However, if it's not with the graphic, they telling you 1 milliamp here. The current flowing here, that means ID. That means you get the ID equal 1 milliamp. So that will be easy for you to calculate from number 1 to number 5. And I already gave it to you. The solution here, make sure you try it, okay? And hopefully you can understand that normally they do it. They don't want to use in the graphic, okay? So if it's not using the graphic, they must be given to you something. If you understand, then you can do calculation, okay? And this is for the voltage divider, okay, with the graphic. If you get the time, you can look into voltage divider bias using a graphic. Try to calculate to get 2 points, A and B. Draw the load line, intersection with the curve. That is the Q point. Okay, I believe this is the solution for you. Okay, normally, bias, they want to calculate the ID, you see that? But this equation very, very difficult when you substitute into the value. No one wants to do it. That's why they come up with the graphic. Okay. Normally, you can see for voltage divider buyer, they don't want graphic. That's why they given you VD equal 7 volt. And they want to calculate everything. Okay. Let's see. Now, before we done for this one, I want you to do a calculation for me. Everything, VG, VID, VGS, VGS, VDS on this problem. Go ahead and do it for me. Make sure we want you to do it. You have to try to do the calculation to see how much you understand. First thing I can given you a VD, a VG, okay? VG equal VDD time R2. And just telling me the value, you get it. Who get the answer for VG?
1.54 volts.
1.64.
54. 54. 54.
54. Okay, and they get a different answer. If it's not, then you need to calculate the ID. The formula for the ID will be equal to VDD minus VD divide RD. That's what I given you the formula. And you need to telling me what you get for ID. What ID equal?
1.5 milliamps.
Okay, get 1.5 milliamp. Okay, if you get the different, let me know.
I got 11.99.
Okay, you get 11.99. Now,
9.8.
what you get? Kumo.
9.8.
Okay, quite different. Let's see. ID
12
equal 12
minus 7 divide
minus 7
3.
divide to 3.3K.
Yeah, 9.8.
Is it a 9.8 milliamp?
1.5 milliamp.
Okay,
Oops.
man. You don't want me to have to do the calculation. You take 5 divide 3.3, guarantee you cannot get bigger number.
12.
Sorry.
Good try.
Ah,
I think 1.5 million.
Okay, thank you. I know, 1.5.
Yep, agree now.
Okay,
1.515.
okay, now we add. When Sam say, I believe him.
3.3 volts.
3.34. Okay, one answer will be 3.3 volt. So just telling me what you get. Different.
Yeah, 3.3 volts.
Okay, perfect. And then VGF.
Negative 1.76.
Negative 7.1.
Oh no, 1.76. Negative 1.
76 volt. That's right.
Sounds good.
Mr. Pham, is there a way you can write the formula for us, please?
For which one?
For both C and D?
C and D. Okay. VF. ID. VGF. VG. Minus VF. And also I given you VDF.
Three 3.7 volt.
You say VDF 7 volt,
3.7.
3.7. Okay, now that is 3.7 volt. It's a very, very basic. You guys try to get along with that. Okay. Sometimes interview they given you very simple thing. And they asking for what we asking here. They want VG or ID or VS or VGS or VDS. And at that time, you don't have any paper with you, any information. Then you have to remember. Sometimes if I given the quiz to calculation, normally I given you the formula. Just try to helping you. Keep doing, and you will be memorize the formula. Sometimes the calculation only 3 minutes, maybe not enough time to looking into the handout to find the formula. No. Okay, any question about this problem?
Sorry, to find the current, ID, that's just voltage divider.
Okay, ID, we already given you the formula, right?
Yeah, I didn't remember it. Sorry.
VDD minus VD.
Yeah.
Divide RD.
Right, RT.
Okay. However,
Okay.
again, if I need on the quiz, I ask you the question regarding calculation.
Yeah.
I try to remember, given you the formula.
Okay.
Okay. More you working on, so you will be memorize the formula. That is the way to learn, the way to teach it. Okay. I don't care pass or fail. I really care when you're looking into the circuitry. If we need the calculation, you can quickly know what formula and how do we calculate it. Okay, so summarize for the JFETDCBias. Okay, also same thing like bipolar, they need the DC power to make the transistor working. In the JFET, they get normally 3 ways to bias. First one will be fixed bias or gate bias. The second one, cell bias. The next one will be voltage divider bias. So when you're looking into the circuitry, you must be recognize what type of the bias. Okay, fixed bias, cell bias, or voltage divider bias. And normally they don't do anything with the graphic. Okay, so for any circuitry need the graphic, normally they can give you extra value. For example, on this one, they given you VD. That will be helping you easy to calculate the ID. Or if they not giving you the VD, then they can give you the ID. If you get the ID, then you can calculate everything you need. Okay, we don't care about graphic. Or sometimes they not given you VD or ID. However, they given to you VS. If you get a VS, and that's easy to calculate the IS, take a VS divide to RS. If you get the IS, that means you get the ID. Remember, for JFET all the time, ID, IS will be the same. So if you understand, it's not hard to do. That's easy. we can get another month, that's a May, and a half month of the June. So that will be we need for the spring 2022. And make sure you download the next handout for the next meeting. That means JFET amplifier. Try to read it. Okay. You have to reading more and more time. Then that will be easy for you to understand. Okay. That will be the last important handout. We have to get through for the electronic. And also, I make sure I remind you guys, you have to go to the lab to do the lab work. Okay? Or for Tech 2, you have to do the lab. Up to next month, I will be going to review for any student. Start from 2020 to see how much you done on the lab work and how much you done on the lab. So we can talking about the completion of certificate. Okay. The thing is, summer 2022, we're not talking about electronic. We're not talking about digital. Only we teach will be AC circuitry. That will be short semester. I believe around 2 months. Not much. So whoever not done, try to keep working so you're able to get the certificate. I believe at that time will be more job for the technician.
So there is a summer course for electronics technician?
Yeah, could be, just you can say, will be more and more job for technician. Okay, from now to up to keep going. The thing is, the company have to be open. So it's a very good chance, okay, for your guy to get a job. If you want to apply for the job and you don't know much company, I will be help. I try to summarize of the big company in San Diego and we'll let you know. The thing is, normally in the San Diego defense company, that is the good one. Okay, any question, anything? Now just bring it up. You know, I still running the program. The thing is, I want to have anyone want to learning electronic, digital, and also the software. In order, you can be technician or you can be engineering, okay? If you keep going. then guarantee next few more year, you can get the job or the degree you wanted. I told you, I get 2 students graduate on 2019. And this year they will be graduate from SDSU with the BSEE. They already talked to me. The program, the electronic program have a lot when they go up there. Okay, any question, anything? Mr. Smith, any question?
Thank you, Mr. Pham.
Can I ask a question from homework?
Okay, Sam will be doing.
Okay.
Okay, the thing is, never send anything to me to asking me to looking into to see try around. No, I don't have a time. If you get homework assignment, talk to Sam. Contact Joe. And the lab, you get a problem, your program, or you get a problem with your hardware, you can text to me. I can be on Zoom with you to help you to solve the problem. Instead, you don't know how to do what to do. Don't do it. If you know how to do it, then you can do. Otherwise, electronic is not lucky. Okay? If you see on Zoom with me, maybe take 10 minutes, 15 minutes, everything will be done.
I will. Thank you.
Yeah, I saw you all the time, right? Okay, now Mr. Sam, can you get the quiz number 5?
I think the student that was going to ask for the homework help, one of the
Okay,
student
I
was,
stop there.
okay, go ahead. About the homework question. What was your question, Nicholas?
Number 7 on assignment 16.
Assignment 16, okay. Question number 7, correct?
Yeah.
Okay. Let me see, share screen. Share screen. So this is what be the formula for doing that. Okay, so number 7. So the gain in dB equals 20 times log of V out over Vn. So 20 times log of open parentheses 1 millivolt divided by 100 millivolt. Okay. And you do that
Okay.
calculation. Okay. So that should comes into about -40 milli, so -40 dB. Okay. So there's a formula that apply to it.
All right. Thank you.
Okay. All right. Any other question? Okay, so now we can do the quiz number 5. Let me go ahead and stop sharing. Okay, so minimize this out the way, close this. Let's start my. All right, so we're gonna be sharing screen. Okay, so, Okay, here we go. Let me see, slideshow, start. Okay, can you see question number 1, 2, and 3?
No, just your photo.
Excuse me,
Just your photo.
You need to
just my
share.
photo. Okay, hold on. Stop sharing, let me see. All right. Let me see, okay, let me see. Share screen. Share screen. Okay. Let me share screen. Okay, let me see, transition.
Okay, look like.
Maximize.
Okay, can you see it now?
Yeah.
Okay.
Hello, Sam.
Yes, Mr. Pham.
Yeah, this the slide may be wrong with the timer.
Okay.
Just
Let me- Okay. Let me see. That's going to be. Okay. Let me see. Okay, give me 1 minute. Let me see if it changed. Not, if not, go forward. Okay, you are correct. Okay, let's go to the next one. Okay, so 17. Okay, look at the timer. This one is off too. Okay. Okay, you have 1 more minute. Okay, so that's pretty much it. Let me see. In the slideshow. Okay.
Hey, Sam, my quiz 5 that I downloaded only had spots for answers up to number 14.
Oh, okay.
Did I add like number 15, 16, 17? To something?
Yeah, you can add on to the sheet. Let me see if it's room that allow you to do it or not.
For me, this protected cells can't be modified. When I tried to add number 15, 16, 17, I could
Okay.
record the answers, but I can't put number 15 next to it and 16 next to it.
Okay, so you just have to do is just open another sheet, another worksheet. Let me see if I let me share screen. Okay, so if you look at, so if I look at their website, just going to go to get the handout. Handout. Okay, so all you want to do is quiz here. Open that up. Okay, enable editing. And then And then just copy this sheet here. So you want to do it, just highlight that, just copy, and then
Yeah.
open up another worksheet. And then come here, control paste it, and then you can add number 15, 16, and 17.
All right.
Okay, and then just put the answer there.
Thank you.
Okay, thank you very much. Okay. 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 Okay, so. Okay, so that's for the answer sheet for the quiz, so. Okay, so don't say that. Okay, so let me see what else was said a minute ago on the chat. Okay, so. Okay, so video upload tonight or tomorrow. Okay. Okay, so Daria, okay, Abdullah has a question on the manual DLAP 9, DLAP 10. Okay, so DLAP 9, DLAP 10 for Tech 2. So let me see assignment. No, what's assignment? Tech 2. Share screen. Okay, so this is what I have for all the Tech 2 students as of right now.
What's up? How you doing?
Your screen didn't share, Sam.
So okay, so sorry, share. Okay. All right, so this is what I have as of right now. This was, I checked it today at 12 noon.
Hey, Sam, what happened with my number 10?
You failed test 3.
Okay, Mr. Pham said we could do it the regular way and the loop, so one of them passed.
Well,
That
you have to
doesn't
do
matter
both
to
of them
me
to
which
pass.
way you want.
Okay, then it should have passed then.
Okay,
The regular way passed.
right.
So that's pretty much what I have for Tech 2 student as of right now. Okay. Okay, so that's pretty much it.
Okay, thank you, Sam.
You're welcome. Thank you.
Hey, Mr. Pham, you're gonna cover the schematic on the DLab 11 on Friday, correct?
You mean I'm talking about that?
Yeah, you're gonna talk about that on Friday?
Yeah.
Okay, thank you. That's all.
Okay, so good night, everyone.
Good night, Mr. Pham.
Bye.
Thank you. Good night.